So good afternoon to everyone. Thank you so much for joining us and welcome to the second in our series of 3 dairy webinars. This one is How Does Agri-Tech Improve Cow Health? So my name is McReddie. I'm the Business Development Manager for Livestock and Aquaculture at Agri-EPI Centre, and I'm going to be your host this afternoon. So we're delighted to have partnered with 2 of our members for this afternoon's webinar. So that's Robotics and Harper University. Before we begin and get underway with introducing the speakers, I'm going to run through some housekeeping for the webinar. So this session is being recorded. All attendees are in mute and listen-only mode. So questions will be taken at the end of the presentation, and you can submit these via the questions bar on the right of your screen. We would like to hear from you throughout the presentation, so please interact with us via the chat function also on the right of your screen. So today we're going to welcome Dr. Mark Rutter from Harper University, Vivi Thorup from Robotics, and Duncan Forbes from Agri-EPI Centre. So without further ado, I'd like to take the first 5 minutes of your time to introduce Agri-EPI Centre to you all before hearing from the first of our speakers. Like I said, my name is McReddie. I'm the Business Development Manager for Livestock and Aquaculture at Agri-EPI Centre. So who are Agri-EPI and what is our position? So Agri-EPI Centre is one of 4 UK Centres of Agricultural Innovation. We are supported and sponsored by the Department for Business, Energy and Industrial Strategy through Innovate UK since 2016. So we exist alongside our sister centres, which include Agrimetric, so the Centre for Data Excellence, the Centre for Crop Health and Protection, or CHAP, and the Centre for Innovation and Excellence in Livestock, CL. So we're centred entirely around our membership offering. We work with people across the agri supply chain, including academic institutions, industry and government, and we exist to facilitate and enable research, innovations and R&D. We work across all the major agri-food sectors, so arable, horticulture, livestock and grass, and aquaculture, and cross-sector. Our members are made up of all kinds of a variety of organisations, so they include everything from academic institutions to farmers, to technology developers, processors, retailers, biotech, engineering, industry bodies, and so on. So why do we exist? What's our purpose and concept? So we have 3 main objectives, and they are to be a world leader in precision agriculture and engineering, to operate a wide range of industry-led activities in R&D, and to ensure that any knowledge generated through our projects and our members' projects is translated and transferred to the relevant audiences. So we like to think of ourselves as the UK agri-tech enablers. So we provide members with access to academics, we broker collaborations and build consortia, test and demonstrate new technologies via our satellite and smart farm network. We help proposal writing and access to funding for R&D. We provide business incubation facilities. Like I said, we have knowledge exchange and dissemination, and we have a team for influencing policy. So as you can see from the map on the left, we have a network of hubs and farms up and down the UK. So the white dots are what we call our satellite farm network, essentially a network of on-farm commercial test beds for trialling, validating and demonstrating new technologies for agriculture. The red dots starting from the top are our Northern Hub in Edinburgh, our Midlands Hub at Harper University, where we're joined by Mark and Duncan from today. Moving across to the east, we've got our Cranfield Hub, which is sort of our crop centre, and moving down to the southwest, we've got our Southwest Dairy Development Centre. So just the last thing from Agri-EPI then is to let you know we've raised a campaign recently that we hope you'll all get involved with. So please do follow us on Twitter and LinkedIn. If you do want to tweet about this webinar today, please use the hashtag Agri-EPI Enabler for all of your posts, and feel free to like and share anything. Also let us know how we can support your organisation. So without further ado, I would like to move on and introduce our first speaker. So Dr. Mark Rutter is Professor of Applied Animal Behaviour at Harper University. His current research is focused on how an understanding of the natural behaviour of domestic cattle can improve their production, efficiency, as well as their welfare. This includes an interest in domestication of the evolutionary basis of behaviour. Mark is also interested in the role that precision livestock technologies can play in promoting sustainable livestock production and animal welfare. He is also currently the supervisor of 3 postgraduate students. So without further ado, I'll move on to Mark.
Right, thank you very much, Casey. Hopefully you can all see my slides and hopefully you can all hear me. Shout now if you can't. So over the next 15 minutes, I'm going to talk a bit about how automated monitoring of dairy cow behaviour on farms has evolved from a fairly simple estrus detection through to sort of modern day health monitoring. But a large part of the talk will actually look at the potential of using the technology in terms of welfare assessment in the future. So I'm going to talk a bit about behaviour monitoring for estrus detection, then move on to talk a bit about how we can use changes in behaviour to help monitor animal health, talk about some of the challenges we face in terms of on-farm welfare assessment, briefly look at some of the major welfare sort of assessment frameworks, and then spend a bit of time looking at where sensor data can actually fit in terms of hopefully giving us a more robust approach to welfare assessments on farm. So really, I think estrus detection is very much the sort of killer application for technologies on dairy farms. Clearly, if you're relying on artificial insemination, you need to get your cow pregnant, so you need to detect when the cow is in estrus. So the first really automated use of farm sort of behaviour monitoring was around estrus detection using relatively primitive pedometers. These would incorporate a tip switch, which is literally not much more than a little blob of mercury sloshing around. It would make contact when the cow moves, and this increase in activity at around estrus could be detected. It wasn't really until the cost of accelerometers came down with the development of smartphones that it became economically viable to start to incorporate this sort of technology into sensors that we're putting on cows. So what I will call the sort of second generation of cow activity monitors included these accelerometers. The accelerometers are far more sophisticated than a simple tip switch, and we could use accelerometers to actually differentiate between different behaviours, very much depending on exactly where on the cow the accelerometer is fitted. So let's look at some examples. So we can look at our cow, we can put a collar around her neck. So an example here is the NEDAP neck collar. So as well as monitoring activity, we can look at time spent eating, time spent ruminating. She can have a sense around her leg, such as the Robotics ice cube. You'll hear more about this from the next presenter. Again, giving us a measure of activity, but also and accurately measuring the cow's lying behaviour, how long does she spend standing, and how many steps does she take during the day. We can also put accelerometers into the cow's ear, again, giving us activity or rumination, or the accelerometer can actually go into a bolus in the cow's rumen, again, giving us measures of the cow's activity. So as you can see here, we can actually use accelerometers on different parts of the cow to really give us quite a broad range of behaviours that we can monitor automatically. But there are sensors other than accelerometers which can be used. I think one of the most powerful ones are starting to come onto the market over the last sort of 2 or 3 years are the cow positioning systems. So again, a location monitoring system from NADAP will tell us where the cow is in the building. Similarly, there's the SmartBow ear tag will give us the cow's location. I think these are being used down on the Southwest Dairy Development Centre. We can also, as well as measuring behaviour using these sensors, of course, there are other parameters, physiological parameters that we can measure. So we can measure the cow's temperature from an ear-mounted sensor, or we can have a rumen bolus giving us the cow's temperature, but also something like a rumen pH, an example being the SmackStex bolus. Of course, we don't rely entirely on animal-mounted sensors. We can have static sensors mounted around the building when the cows are moving around. We might have a weighing platform giving us live weight. Obviously, when the cows are milked, we can automatically record milk yield. But a 3D camera, such as the Delaval BCS camera, can give us the animal's body condition score. So we have quite a broad range of parameters that we can measure. So as I mentioned earlier on, most of these systems were originally sort of designed to really improve the reliability of estrus detection. But just as we see changes in the cow's behaviour with estrus, when a cow is injured or when she's sick, we'll also see changes in her behaviour. So for example, we worked on a project led by Robotics, and again, Vivi will talk a bit more about that next, where we use their leg-mounted sensor to help really provide a system that will reliably give us an indication of the very earliest signs that a cow is starting to go lame. And again, it can pick up some really subtle changes. This is now available for on-farm use and Vivi will talk about that a little bit later on. As part of that project, we also thought it'd be interesting to look at, can we start looking at other diseases, and do we find behaviour changes that are sort of associated with particular diseases? So we looked at cows that were both testing positive and negative for Lameness disease. Those of you with links to the industry obviously know Lameness is a challenge in terms of reliable detection. Crucially, these cows that were JD5 were Lameness positive. They weren't showing any clinical signs when they were on this trial, so we were in that preclinical stage, and we looked at the lying behaviour of these cows. So these results were recently published in the Journal of Dairy Science, and what we found was that the Lameness positive cows had a lower daily lying time. It seems maybe slightly paradoxical. You'd think a sick cow would spend more time lying. What we've subsequently found is actually in this early stage of the disease, they're spending more time eating, which impacts on lying time, but also their lying bouts were changed. So they had fewer of them and they were longer. And we think this might have been associated with discomfort in terms of lying and standing. Lameness is a gut disease, and we think it may, the cows may find it a little bit uncomfortable getting up and getting down, which is why we've seen these particular changes in lying behaviour. So I think the next question is, well, are these particular changes, are they unique to Lameness disease? I think we've got some reason to suspect they might be, but can we detect other changes in terms of the cow's behaviour that would indicate other diseases? So are there particular behaviour changes associated with mastitis, say, with ketosis? Can we detect these using the technology? So I think this is going to be the exciting phase, probably for the next 5 years or so, where we move from simply detecting that a cow is perhaps unwell from disease detection into disease diagnosis, and we can actually start to use the data coming from the sensors to tell us, you know, specifically we think this cow has this particular condition. So health is obviously an important component of animal welfare, but I'm going to move on really for the remainder of the talk to talk a bit about how the data might actually be used in the future in terms of welfare assessment. One of the challenges with animal welfare is there's no simple iceberg, there's no one single indicator that will tell us the welfare status on a particular farm or of a particular animal. Perhaps not surprising, because lots of factors contribute to animal welfare. So, for example, the Farm Animal Welfare Council's 5 Freedoms, we'll look at that in a moment, has a number of different factors. But this really presents a challenge when it comes to trying to assess animal welfare on farm. So current farm welfare assurance programs, such as the welfare quality system, I'll talk a bit about that in a moment, relies really on farm visits by auditors. So these can cause some challenges. They're very time consuming, so they're therefore costly, but also they're comparatively infrequent, only happening maybe 2 or 3 times a year at the very most. So they give us this infrequent snapshot, and they also rely very heavily on resource-based measures rather than animal-based measures. So might we be able to find a better way of providing information relevant to farm animal welfare assurance using the data? So let's just have a look at sort of 3 of the current frameworks that are used in terms of welfare assessment. So the Farm Animal Welfare Council 5 Freedoms, looking at freedom from hunger and thirst, freedom from discomfort, freedom from pain, injury or disease, freedom to express normal behaviour, and freedom from fear and distress. This has been around since the late 1970s. It's had a few sort of iterations, but it's become pretty much a fairly widespread approach, and indeed actually forms part of some of those guidelines go into the current UK Animal Welfare Act. But in terms of welfare assessment, the Welfare Quality Programme, a large European programme, was set up to actually look at this and develop some protocols. And you can see these map actually pretty closely to the 5 Freedoms. Again, we're talking about feeding, environment, health, appropriate behaviour. But you'll notice we've increased the number of criteria slightly, so we actually have 9 within the 5 Freedoms, there are 12 within the welfare quality. The most recent one, welfare, the MELA's 5 domains, has no less than 118 factors that actually contribute towards welfare assessment. So actually, protocols around measuring welfare are actually getting more and more complicated rather than simpler. So it's going to become an even bigger challenge to try and do these on farm. So where might we use automatically recorded behaviour data to actually underpin what we're doing in terms of on-farm assessment of welfare? Well, you might think at first that Behaviour monitoring really only fits into the appropriate behaviour category, and then even within that, it's really just looking at social behaviour and other behaviours. What I like to argue is that it actually, I think it actually fits pretty much all 12 criteria. So let's look at some examples. So good feeding, clearly we're looking at hunger and thirst, trying to avoid those. Those are internal mental states, so we can't access them directly, but actually feeding behaviour, body condition score will allow us to start to estimate whether or not we think the cows might be going hungry. And we can look at drinking behaviour, really give it quite a good indicator of absence of prolonged thirst. The good environment is all around a comfortable resting place. So something like Robotics Ice Cube will give us lying time. You might use a location system to look at where are the animals lying, is there any competition for lying space. Thermal comfort, the tracking system might tell you, are you getting cows crowding into particular areas, avoiding other parts, possibly because the temperature or other environmental conditions are inappropriate for them in those areas. And ease of movement, so again, just the amount of time the animals are moving around, how they're using space, would also give us an automated way of sort of estimating ease of movement. Health monitoring, if an animal is injured, we'll likely see changes in her behaviour, and again, those can be automatically monitored. We're likely to see changes in behaviour associated with disease, for example, being illness disease and lying behaviour. And again, the idea of avoiding absence of pain induced by management procedures. If we knew when those procedures were, hopefully there would be a log of that. We could look to see if there were behaviour changes afterwards. Of course, not surprisingly, automated behaviour monitoring fits in very well with appropriate behaviour. So we could look at the interactions between animals using the location data to look at social behaviour. Have we got relatively stable social groups within the herd? We could look at the expression of other behaviours in terms of natural behaviours such as foraging. This might integrate actually a range of behaviours we've already looked at. And if we knew where the farm staff were, they might need to carry the same sort of technology that's tracking the cows. We can actually look at how the cows interact with the farm staff, and we can actually detect, have we got generally positive interactions there, or are the cows clearly trying to run away from particular members of staff? I think the only one that it would struggle a bit with is the positive emotional state. This really is an internal state. There's no direct measures, but actually what we would do here is we would integrate all of those behaviour measures across the other principles to give us some indication that we think the animal is experiencing a positive emotional state. So what might it look like? Well, actually, we'll look at that in a moment. So what the argument I'm trying to make is actually behaviour monitoring, I think, has got a role to play across the assessment of pretty much all of the criteria in the welfare quality programme. There still needs to be some research in terms of really understanding where that data fits into the current assessment protocols, and it probably really needs the welfare quality protocols to be revised in the light of this new source of data. But I think over the next 5 years, we'll see research will hopefully move us in that sort of direction, and then within 5 to 10 years, we'll actually see these sorts of approaches being able to be used on farm, both to help the farmer, inform them around what they need to do to make sure they've got good welfare on their farm. But clearly, this evidence is also important in the supply chain, that this data could be made available through the supply chain to actually demonstrate the very high quality of welfare that's been found on particular farms, and that is all underpinned by very objective data that's actually been collected. So what might it look like? I'm not going to go through this slide in detail, but just to say we have a range of sensors on the cows. These will give us a range of different data. So the EATAG accelerometer giving us position, movement, rumination time, for example. Leg-mounted accelerometer looking at lameness probability, step counts, and lying times. And these map very nicely onto those welfare quality criteria, as I just mentioned. But crucially, it's going to let us change some of those measures that are currently really resource-based into animal-based measures. So rather than in terms of absence of a long thirst, rather than just check have the cows got an appropriate number of water troughs, we can actually look at drinking behaviour, and we can actually use an animal-based measure. So just to summarise, hopefully we've demonstrated that automated on-farm cow behaviour monitoring was really first developed to help detect estrus. I think the exciting developments we're going to see, well, we're already starting to see, is that we can use behaviour change to help detect injury. But it's also going to become increasingly important, I think, over the next 5 years, in allowing us not only to detect but also diagnose disease. Animal welfare is complex, it's multifactorial, and manual assessment is welfare and time consuming, but we have the potential of using sensor-based monitoring to really ensure that farm assurance schemes are robust and are very much based on evidence. So I'd like to thank you for your time. I'm hoping there might be some questions at the end, but I'll hand back over to Casey.
Thank you very much, Mark. Thank you for giving us an insight there and an introduction onto sort of animal behaviour and welfare and the use of agri-tech. So next up, we've got Vivi Thorup, so a trained biologist with a major in animal behaviour and a PhD in the biomechanics of four-legged animals. So Vivi lives in Denmark and started working remotely for ICE Robotics about 5 years ago. Vivi provides scientific and strategic advice to the management team, and she is responsible for all the R&D related work that ICE Robotics perform in the animal science field. So it's over to you, Vivi.
Thank you, Cassie, and thank you for inviting me to present at the seminar. So I'll go straight into it and say something about how cow alert sensor technology is able to improve cow health and welfare. And today's topics in my presentation will be a little bit about how cow alert itself actually works, and I'll also mention the DAISY projects in which we worked on data coming off Harper University, which is the facility, one of the facilities of Agri-EPI. I'll discuss lameness detection that Mark already mentioned. I'll discuss line time, summarize in some insights, and just shortly mention some future releases that we have planned. So Cow Alert is the world's first cloud-based health monitoring system. We launched it for commercial farms in 2011. It simply works by use of the sensor on the cow's legs. That sensor is read by an antenna. It is then directed to the local farm server, and then via that server to the Cow Alert cloud, which we have access to 24/7, of course. And we continuously develop new features for that system. Regarding the DAISY project, this was a project, like I said, we used data coming off, among others, Harper University. There were also 6 commercial farms involved where we collected data. DAISY actually stands for Dairy Animal Sensor Integrated Engineering. It was a large, almost 2 million project supported by Innovate UK with 4 partners, so Kingsay, Müller, Harper University, and ourselves, plus the commercial farms, and this was a project which ran from 14 to 17. And it helped us develop various things. Among other, it helped us validate sensor output. It enabled us to develop automated lameness detection. We also were able to show the existence of a line time curve, and we've progressed from doing simply estrus detection to now also do more advanced fertility features. And also we developed a mobile system that actually works in farms where you can monitor fewer numbers of cows, but you can then move your system around with the infrastructure quite easily. So back to lameness detection. Well, this might not be news to anybody, but I'm just going to recapture quickly. Lameness is one of the 3 most expensive production diseases in dairy production. Roughly 30% of cows in the UK are lame at any one time. The issue is most farmers only spot 20 to 25% of those lame cows, and also lameness is a symptom of pain. So with automated lameness detection, we feel we're addressing a cow welfare problem. And all of these things also can be summarized in saying, well, too many cows are in pain for much too long as they go on undetected. So how do we do that? Well, we're obviously using the data coming off the leg sensor. We also take some farm KPIs and the cow's birth date, and we put that into an algorithm which I developed using the data from the DAISY project. And using that data, we produce 1 value per cow per day, which is on a scale from 0 to 100. And if the number is below 50, we consider that as a healthy cow. If the number is above 50, we consider it to be an attention cow. And above 70, we consider it a lame cow. But those categories are flexible, so the individual farmer is actually able to adjust his thresholds to fit his needs and his lameness levels. Just to give you an example how that actually looks, this is one cow that was monitored for 2 weeks. The daily dots are the blue ones, and the amber line is the attention alert threshold, and you see how an attention alert was issued, and then a few days later the alerts exceeded the lameness alert threshold of 70, and a lameness alert was issued. That cow was then checked by a vet and lameness expert a few days later, and he diagnosed the cow with a sole ulcer, and he gave it a visual mobility score of 3. So that supports nicely how that pattern looks. That vet also said it's quite normal for cows' visual mobility scores to fluctuate a little bit over time if you do them frequently enough. And so his appraisal of this was, this is what he would have expected to see in a cow, not a straight line going up, but something which fluctuates a little bit and then starts showing an increasing tendency. I would also like to show how lameness in general affects behavior, the way we measure it from our sensors. So we took the Harper Adams data, and for this purpose we had over 6,000 cow days of data. We looked at the lame cows, the older lame cows, and in this case lameness is mobility score larger than 2. On a scale from 1 to 5, so not the AHDB scale. And as you can see, the red line are the lame cows, the black line, the normal cows, and on your left you've got line time, and you can see how line time describes first the high. It goes down to sort of a minimum 4 to 5 weeks after calving, and then starts increasing again, which is the normal pattern that we've seen in multiple herds by now, and it's been published in a few papers now. And what we did test statistically was that line time did increase, mainly during early lactation in these lame cows. And on your right, you'll see step count, which is sort of showing the opposite, that the lame cows in the red line have a lower step count. I would also like to take the opportunity to show how lameness and milk yield is, how they are connected. I think it's often overlooked how big an economic impact lameness has on the farm economy. I think it's sort of like a hidden cost to many farmers, but in this plot you will actually see the black lines, which are the milk yields, and it's split by parity, so parity 1, 2, and 3 above. Data coming off a Dutch farm across 230 lactations. And it's interesting to see how with increasing parity, yield increases, but in the red line also lameness probability increases. And this is also in concordance with several scientific studies. So switching over to line time, when we monitor line time 24/7, it allows us to, for instance, identify cows at risk. And this could be cows with very high line time or very low line time, and that could be indicators of lameness or other types of disease. It also enables us to assess management processes and procedures, for instance, group changes, disturbances, excessive use of headlocks, idle waiting to get milked, etc. And it's also a potential metric of animal comfort. During the DAISY project, the postdoc of Mark Rutter was kind enough to perform this validation. She looked at a lot of cows, both in at pasture, in cubicle housing, and in a straw yard. So she looked at them visually, and she compared the visual observation to the ice cube output, and found that the line time measurement was highly accurate. What I also want to show you is how we feel a line time curve is not as simple as many people might think. It's not something that increases linearly from days in milk and onwards. It actually has a curve. It starts high, has a very low nadir 4 to 5 weeks after milking, and then increases back up to a plateau. And I think I've got the hours as well. Yeah, it starts out at 13 hours. That's actually during the dry period. Again, data from Harper herd, where we were able to also capture data in the dry shed. 10 hours is the minimum during early lactation, and please note that this is appearing 4 to 5 weeks after calving, and then the plateau around 12 hours a day. So my question when I started seeing these patterns from multiple herds, not just the Harper herd, is that, do we actually need to consider extending the transition period to be longer than the normal 3 weeks after calving? Because it seems like the cows, when they're experiencing their minimum line time at 4 to 5 weeks, they could appear as more vulnerable than we really realize during that transition. Another example, which is more like a case study, is from a large commercial farm in the States, where at the installation of Cow Alert, they started looking at line times in a 3,000 cow unit, and they were wondering why they were seeing low line times. So what they did was they changed bedding maintenance from 1 hour a week fresh sand bedding, and up that to twice a week fresh sand bedding, and that helped them increase line time by 1 to 1.5 hours a day, which is quite significant. And that despite being this taking place during the middle of peak grazing and heat stress periods. So we talk a lot about the average herd line time, which the recommended number for that is 12 to 14 hours a day. However, I think a lot of farms would struggle to actually reach that recommended average line time. And if you look at variation across a herd, you start to appreciate why. Again, this is numbers. These numbers are from that large US herd, like you saw on the previous slide, which averages now 10.3 hours a day, which is not bad, but it's not 12 hours, and it certainly is far from 14 hours. So a large herd, most of the groups milk twice a day. Maybe the high yielding cows are milked three times a day. So that would steal even more time for the cows to be able to lie down. Nevertheless, 10.3 hours a day line time. But my point is, should we focus only on the average as the metric that we want to measure welfare by? I think we should broaden our horizon a little bit, because if we look at cows at the extreme ends, what's causing them not to achieve the average? You could easily have a very nice average and then have a number of cows at either end of the extremes that are certainly not achieving the line time that they should. And I've tried illustrating that in these pink areas where, well, those are the cows outside the recommended average line time. And I would encourage the farmers to go and check on the cows or the groups that are underachieving the line time, and see what type of disturbances or what type of management is actually taking place in those groups or with those cows. Are they suffering from some sort of disease? So in summary, we can pick out lame cows automatically every day because we monitor the cows 24/7, so we don't miss them, and we do it consistently, and there's no bias in the data. It's a machine learning algorithm which will perform regardless which farm it is. We also feel we want to stress that line time is a proxy for cow comfort, which probably plays well into what Mark Rutter said before about measuring cow welfare automatically. We think we can contribute to that, certainly. And also it's important for us to stress that lying time is not a simple metric. We need to appreciate that there's a development across lactation, and do consider that when you assess your cows with respect to lying time. Is she early lactation? Is she late lactation? What is she? And doing so, remember that a nice average may mask extreme lying times where you will find those at-risk animals. So in short, there's no silver bullet here. Technology can point out problems. However, the farmer still needs to go and solve them. And the last slide is on future releases. This is something which is coming out very soon to be released. The first part is to do with more advanced features of fertility metrics. So we will be producing alerts that will point the farmer towards non-cycling or irregularly cycling cows, because these could be signs of, for instance, metritis or perhaps a negative energy balance. We will also be providing an action reminder list to ease the daily life of the farmer. So the farmer will be reminded of when to inseminate, when to preg test, etc., etc. And we'll also be providing some fertility KPIs. So I'm just mentioning a few because I think we've got 9 or 10 coming up, but some of them would be overall preg rate, 200 days in calf rates, mission rates, things like that. And this should allow the farmer to manage his herd better and to perform some real-time benchmarking, because these figures will be real-time. They will not be based on something which happened last year or 3 months ago. This is every day updated. And finally, we will be releasing the ability to perform calving alerts, which will enable the farmer to do early intervention in case there's an issue with calving. And that's basically it for me. Thank you very much.
Brilliant. Thank you, Vivi, just giving us an excellent overview there of a piece of technology that has a real application on farm. So we're going to move over to our final speaker for the day, my colleague Duncan Forbes, Head of Dairy at Agri-EPI Centre. So Duncan has a wealth of experience in the dairy industry. After several years in practical farming, Duncan moved into farm management consultancy and worked for over 20 years as the Managing Director of Kingsay. In his current role for Agri-EPI Centre in Somerset, Duncan is focused on the development of the dairy research and demonstration facility for 180 cows, combining robotic milking and feeding in a state-of-the-art building with precision grazing. So we can see your presentation on your screen now, Duncan, and it's over to you.
Okay, thanks, Cassie. So today I'm going to be talking about the facility we have here in Shropshire with Harper Adams. It's one of a number of facilities that we have been able to invest in. Cassie mentioned the spread of our assets. So I'm normally based in the Somerset unit, but we're here in Shropshire today. But we also have a calf rearing facility in Dumfries with SRUC, and the white dots are then some of our commercial satellite farms that have dairy on them. So the Midlands Dairy Research is very much a specialist research facility that's set up to study cow behaviour and working very much with Mark to get this built and set up. It's built for 60 cows with 50 in milk with a year-round calving pattern, you can see in the middle image where the building is relative to the Harper Adams main dairy unit, which is in the bottom left of the picture there. So the layout is straightforward, if you like, in that there are 56 cubicles. It's feeding down the outside of the building, and the single robot is located centrally. And what this building has, beyond what you would normally have, is these areas at each end of the building where trials can be conducted. And so you can configure it to have 2 groups of cows. The cow flow is controlled so that both groups of cows still access the same robot, but obviously return to their different parts of the building as they go. There is going to be the facility to enable the cows to access pasture areas as part of the behavioural studies that may be done in future. This won't be the full-on grazing, but it will enable cows to choose to leave the building if they want to. So if I can just get this to go again. So the automated milking system is a de Laval system, and so it's serving all the cows. The video there shows you the action of this particular robotic system, which is putting, after it's cleaned the teats, it puts each individual cup onto the cows with one robotic arm doing all of that. Mark mentioned that there is a body condition scoring camera. This is something that will automatically measure the body condition of the cows as they're exiting the robot. Beg your pardon. So the building is cleaned by means of robotic scraper. So the de Laval's robotic scraper, which can be programmed to follow different routes around the building. As it goes, it sprays water ahead of itself, which helps to lubricate the waste before it pushes it down the slatted channels that there are in the building. The right-hand picture shows it in its docking station, where it recharges and reloads the water. Part of the building also has this slatted floor, which is a combination of concrete with rubber, which provides hopefully the optimal footing for the cows on a slatted floor arrangement. The cows are in the cubicles. The cubicle divisions are made of plastic, so they're flexible, and the benefit of that being that it reduces the potential for injury that you might experience for cows in the more rigid steel cubicles. So the cows do share space with the next door cubicle, and as you can see, it's in contact with the cow there, but it's giving way, so there is very little in the way of pressure on the cows. So the configuration in order to then conduct a behavior trial is that you're still got your main housing area and still feeding down the outside of the building, but you can separate out a number of cows, give them access to some of the barrier feed here. And in this case, I'm just going to talk about this particular behavioral trial, but and I'll show you some pictures in a moment of how the cows, the area is being set up to test their willingness to walk to different lying surfaces. So it's a very flexible space that can be used for all sorts of different behavioral trials. And in that previous diagram, you could see the dotted lines. And what it is a series of hurdles creating walkways so that it's giving routes where the cow can either be asked to walk 30, 67 or 112 meter distances to access the lying areas that are set up. And in the bottom left picture, you can see the cows on a straw bedded area. So the robot milker is away to the left in this picture. And this is just a walk through the thing. It might remind you that when you were able to fly by EasyJet, you seem to remember some sort of queuing system like this, albeit you didn't end up in a sandpit when you got there. But just to give a feel for you know, the sort of things that the behavioural test trials can show. Here we are, the cows that have taken the trouble to walk the distance to, in this case, a specialist mattress area, and you can see them skipping around as if they were on open pasture, and indeed some of the other cows getting quite excited and wanting to come and join them. So there's a lot of opportunities for us to be able to conduct these sort of things, which would be very difficult to do on any sort of normal commercial farm. I beg your pardon, we need to get out of this one. And so just really to conclude, you know, where the Agri-EPI Centre is very much into using technology to optimize cow welfare and productivity. And that's absolutely key to business resilience, because behind all of this is a really important thing, which is we have to produce more food, not just here in the UK, but globally, to feed the forecast increase in world population that we're expecting between now and 2050 to 9.5 billion people. We have to produce that food with less impact. And so what we're looking at here is the closed loop dairies, where healthy livestock is absolutely central to it. And what we need to understand is what is the healthy environment for the cows, and it's certainly going to involve a lot of what we've been seeing in this building here today, to generate healthy livestock themselves, then creating healthy food, and most importantly, for sustainable and resilient dairy businesses, is that those farms need to be genuinely profitable so that they can reinvest in the future and into the healthy environment. It's not just the cow environment, but the environment in general. So much of what we're doing is focused on this target of net zero carbon by 2040, right across all of the work we're doing within the Agri-EPI Centre. So thank you very much for listening, and back to you, Cassie.
Brilliant, thank you, Duncan. So I'm going to ask all the speakers if they can turn their cameras back on, please, and I will do the same. And we're just going to head over to some of the questions that we've had through from our audience. So I'm going to start with the first question that came through, which was for you, Vivi, from Shane Burns. And that's, how was the lameness detection system validated? I assume it was validated across other farms or farm systems. Please remember to unmute, Vivi.
Yeah, sorry about that. I remember the camera only. Yeah, we've done various different things. It's been validated using, we've done a small trial using ketofin, simply to see if ketofin would decrease the lameness probability in the lame cows. It was just a small trial because ketofin is expensive. But it did show actually that particularly the moderately lame cows decreased their lameness probability. And this was on a, comparing the day before a claw trimming to establish what type of lesions they had, and then comparing to the next day where the ketofin was still active. So comparing before and after trimming. We've also used thermal image cameras on various farms to go and investigate the lesions, because what we're detecting are early lesions, and oftentimes they're very, very difficult to see with your own eye. It takes a very skilled trimmer or a very good vet to actually notice that something is wrong with that claw. Oftentimes it's just an increased temperature of the claw, which you can feel by the touch, but if you don't touch without gloves, you can't feel it. A thermal image camera will show you the hotspot, oftentimes of a sole ulcer starting to become visible. And that's the type of studies that we've used. Yeah.
Excellent, thanks, Vivi. I'm going to move on to one more question that we had for you as well. So that is, do the highest producing cows or the healthiest cows have 12 to 4 hours lying time? And did this information come through in your data set?
I can't actually answer that because what I showed you, that I'm thinking the plot was sparked. The question was sparked by the plot where I showed milk yield and lameness probability. It was an average across the entire group of cows. We didn't in particularly look at which cows were the higher yielding. Did that also correspond to the higher lameness probability? So it's more like a first glance to see, does it actually corroborate that when we find high lameness probabilities, it is in the older cows, which science has told us that that happens because the older the cows are getting, the more likely it is that they will become lame, which is maybe that's obvious, but being able to show it is actually very useful. So that still remains to be proven. And also, milk yield is difficult because yes, a high yielding cow may more often be lame, but not necessarily because she's high yielding. It just so happens that she's at that well, her entire system is probably at that fine balance where not much is needed to tip her over the edge. So yeah, that probably doesn't answer exactly the question, but no, we've not proven that, but we can get there to show it. I don't think all the high yielding cows are necessarily the lamest ones. They can be managed to prevent that. So yeah.
Okay. Brilliant, thank you. So another question come through here that's not for any person in particular, so I'll wait to see which one of you wants to pick this one up, but it's essentially a question about cost benefit. So what is the cost versus the gain or saving equation for the use of some of these monitoring technologies?
Well, every health condition has a considerable cost to it, and indeed Kingsley has been involved in monitoring those and reporting those to people who use the Dairy Manager Costing Service for a long time. And so without being specific, the costs of the three main issues are very considerable, and the cost of the monitoring equipment is more than adequately covered on all but the very best health status herds. It's just, it gives you all of these sensors. You know, the difference is, however good a stockman you are, you cannot be watching every individual animal 24/7. You know, and as Mark was saying, the algorithms that are being developed, which have come from just detecting estrus through to now the things that are able to monitor, as Vivi was talking about, is just the opportunities for improved animal welfare and thence productivity, and thereby not just cost saving but improved profitability, is massive.
Okay, we've got a sort of secondary question come through to that, Duncan. This is from Julian Gardner at Rosaire, by the way, so hi to Julian. Do farmers believe the cost benefit argument though?
I was thinking, as I was saying what I was just saying, if you line up all the technology and the claims each one of them is going to give you, you know, your bank balance is going to look fantastic in no time. So you should have stacks of them on your cows and add them all up. And clearly that's not how it works. And then you know, the challenge for producers is deciding which is the technology that's going to be best for them. And then there's another challenge beyond that, which is that having chosen what technology is best for them, is getting the data from those different elements of technology integrated. Because every farmer I talk to says, I do not want to open 7 different screens in order to then have to make up the decision in my head. I want all the data to be integrated into a sensible central dashboard that gives me the management decision information.
Excellent. Another question that we've got come through here, aimed for you, Mark, from Lisa Morgans. What do you think made heat detection technology so well accepted and adopted in dairy farming compared to many other technologies available at present?
It's a good question. I sort of describe it as the killer application, really, that as we're selected for high yielding cows, we're sort of selected against the expression of estrus behavior. So that's gone down from being an average of 24 hours, a 24-hour window down to 12 hours. And crucially, if you're a dairy farmer using AI, if you don't get your cows pregnant, then you're not getting any product. So you might argue you can sort of get by with a few cows that perhaps aren't at perfect health, but if you're missing getting them pregnant, and I think the other reason why it's been adopted is we actually see quite a big change in behaviour. So it's been relatively easy to detect. That's made it relatively reliable, comparatively reliable, and actually the systems now are all pretty good. So I think a combination of this killer application, you've got to get cows pregnant. It's a system that works, and actually that cost-benefit side is relatively easily demonstrated. I think we need to do more to make sure we can demonstrate these health benefits. And I think it's going to be a challenge around the welfare benefits, because that's where, can the farmer use that data to actually command a premium for his product through the supply chain by demonstrating he's got this really high quality welfare on his unit. So I think that's sort of in a nutshell where the challenges we're going to face in the future.
Brilliant. We've got 2 more questions and 3 more minutes, so I'm going to try and get through them so that we've answered everybody. There's one here, Duncan, for you, which is, how does the Agri-EPI dairy facility in the Midlands at Harper Adams fit in with the portfolio of dairy facilities that Agri-EPI have?
Yes, good question. What we've got is we've got 2 dairy units as such. So the one we've been speaking about today, which is very much aimed at the cow behaviour research. We then have the Southwest Dairy Development Centre, which has 180 cows. It's combining state-of-the-art housing and automation with precision grazing, and indeed is going to be driving towards becoming an exemplar of the circular dairy concept. The third asset that we've got is on calf rearing, on the calf facility. So we're able to research different calf rearing techniques, and that's based in Dumfries, the Crichton Royal farm. And in addition to those, we have then the commercial satellite farm. So you can go all the way from fundamental research right through to the coalface on commercial farms.
Yeah, quite right. And it's across, a plethora of different systems, isn't it, as well? So last question here is for Vivi. It's back to a specific slide you had in your presentation. You had a picture of a cow highlighted with a graph with blue dots. And Neil Thornburg is asking if the farmer had noticed any changes in the cow, and if so, when?
No, I can say that with quite good ease. He hadn't. That data came from a farm which is not very focused on detecting lameness, which made a very good case for us to actually find lame cows, because that's what well, if you go to very well managed farms and we don't have very many lame cows, it's difficult to develop anything. We need cases of medium and more severe cases, and that farm unfortunately presented a lot of severe cases, and he in general didn't really notice lameness, which was lucky for us, but not a very good case in general for dairying. So I think my reason to go there again was to say, look, the data can help you point out where to look and go search, and maybe the data can also help you realize that foot trimming needs to be taken care of more often than your current protocol. Unfortunately, that's the reality in a few farms. We also go to very many well-managed farms where the system can pick out cows that the farmers didn't see, and sometimes we also miss, so it's not 100% correct, and I will admit to that, because no system is 100% correct, but it's by and large we do pick up the early lesions quite well.
Yeah, a fantastic example, isn't it, of agri-tech sort of doing a job for a farmer in terms of early detection. So we've gone through all the questions there. So the last thing really is just to say thank you to all of the speakers that have joined us today for all of your insights and expertise and for sharing that with our audience. And thank you to you for joining us as well. If there's any questions we did leave unanswered, which I don't think there was, we will get back to you via email, and you will hear from us in a follow-up anyway. There is one more webinar left in our series of 3 webinars, so please do join us next Thursday at the same time as Duncan and I head up to Dumfries to the Agri-EPI calf facility, where we will be joined by SIUC and VOLAC to discuss calf health and nutrition. So that is all for today. Thank you again to all of our speakers. Thank you to our audience, and a reminder, join us next week and #AgriTech Enabler. Thanks very much.
Thank you. Have a nice day.
Bye.